Welcome all the student in our YouTube channel Physics by TC Chauhan sir. Today we are going to discuss about cross product or vector product of two vectors. Listen, whenever two vectors are multiplied, then resultant quantity is found to be a vector quantity, then this is known as vector product. Since a cross sign is used in this, that's why its product is said to be cross product as well. It is taken in terms of torque, in terms of area, in which resultant is a vector quantity. Like torque is vector product of force and perpendicular distance, like area is vector product of length and breadth. So such quantities we shall discuss in this video. Let us discuss cross product of vectors. How to study cross product? Let us discuss cross product. Cross product is also known as vector product. So what is vector product? Product of two vectors is a vector quantity, then it is known as vector product or cross product. That is, product of two vectors is a vector quantity, then it is known as vector product. For example, torque. Tau vector is equal to R vector cross F vector. For example, area. A vector is equal to L vector cross B vector. So the thing is, product of two vectors is a vector quantity. It is essential. Then it is known as vector product or cross product. Here we use cross sign. Sign is like this. A vector cross B vector is equal to AB sin theta n cap. Here sin theta is taken and n cap will show that this quantity is a vector quantity. It will behave like a vector quantity. It is a vector quantity. So it will indicate, whenever n cap is there, it will indicate that it is a vector quantity. A cross B is equal to AB sin theta n cap. Listen, if theta is equal to 0, then A vector cross B vector will be 0. If theta is equal to 90, then A vector cross B vector is equal to AB n cap. Here sin 0 was 0, here sin 90 is 1, so AB n cap will be there. A vector cross B vector is equal to AB n cap. This is about cross product. This is about cross product of two vectors. Now what about quantities A cross B is directed according to right hand thumb rule. Right hand thumb rule. Its direction can be shown according to right hand thumb rule. What about this rule? If we consider a right hand and such that its thumb which is stretched and fingers of right hand which are folded like this, I am drawing this. This is thumb and this is right hand. So here, if fingers show A to B, this is A vector, this is B vector. These are bent according to A to B, just like A to B. Then the stretched thumb will show A vector cross B vector. If fingers of right hand are folded from A to B, then thumb will show A cross B. This is the direction of A cross B. Hence, the right hand thumb rule is used according to this. So, this is right hand thumb rule for direction of A cross B. Now, the important quantity is A cross B never equal to B cross A. Then what about their relation? The relation will be like that. A cross B is equal to minus B cross A. A cross B is equal to minus B cross A. It is just reverse. It is against, not along that. Another thing is, that means a commutative law is not followed here. But in the case of A cross B plus C, we consider about distributive law, then this will follow. A cross B plus A cross C. So distributive law is followed here. Distributive law is followed in this. So distributive law is followed, but commutative law is not followed in cross product. Now what about unit vectors? Cross product of unit vectors. In the case of unit vectors, cross product will be like this. I cross I. I cross I will be 0 because I and I both are in same direction. So theta will be 0, and whenever theta will be 0, I have told you A cross B is equal to 0. So this phenomena is applicable here. I cross I is equal to 0. In the same way, J cross J will be 0. In the same way, K cross K will be 0. But I cross J is equal to K. J cross I is equal to minus K. J cross K is equal to I. K cross J is equal to minus I. K cross I is equal to minus J. I cross K is equal to J. So this is K cross I is equal to plus J, and I cross K is equal to minus J. These are few phenomena. It's very simple. You just mark circular position of I, J and K. Then if along this circle the concept is there, the positive sign is used, and opposite to this circle the concept will be of negative sign, like I cross J plus K, I cross J plus K, J cross I, it is reverse, that minus K, J cross K, J cross K, then I because it is along the circle, K cross J minus I, K cross J minus I, opposite to circle, then K cross I along the circle plus J, then I cross K opposite, so minus J will be there. Listen, if A vector is equal to A1I plus A2J plus A3K, B vector is equal to B1I plus B2J plus B3K, then what about A cross B? A cross B will be like this. Put here I, J, K, A1, A2, A3, B1, B2, B3. How to solve? It's very simple. I cap, just take its determinant. You know how to solve determinants, very simple. Just take I cap, multiply them, A2, B3 minus, this is vanish, and these two multiplication are taken, this into this minus this into this, that is A3 B2 minus J cap, just remove this and this, just multiply A1 B3, A1 B3 use negative sign, A3 B1 plus K cap, just remove this and this row and this column, multiply these two in cross, A1 B2 minus A2 B1. This is A vector cross B vector. So how to find A vector B vector? Very simple. You have to mark in determinants I, J, K, A1, A2, A3, B1, B2, B3. Just remove this one and this one, A2 B3 minus A3 B1. Just remove this one, A1 B3 minus A3 B1. Just remove this one and this one, A1 B2 minus A2 B1. Very simple. This is way how to solve determinants. Then application is area of triangle. Area of triangle is equal to half A vector cross B vector if A vector B vector are sides of triangle, if these are sides of triangle. Then area of parallelogram. What is area of parallelogram? That will be A vector cross B vector. area of parallelogram magnitude of A vector cross B vector. You can find it directly. If you have to find vector triple product, there is vector triple product also. What about vector triple product? Vector triple product. Vector triple product will be like this: A vector dot B vector cross C vector. It is having scalar as well as vector product, then it is vector triple product. You can say A, B, C, right? It can be written like that. So A dot B cross C will be in determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. Its solution will be like this, as we have done earlier way how to solve determinant. By this you can solve them. A dot B cross C is equal to ABC A1, A2, A3, B1, B2, B3, C1, C2, C3. Out of them, if one quantity is common, then its resultant will be 0. Like if you are going to write A, B, then it will be 0, because you know whenever one row is common, then its answer will be 0. It's very simple. Whenever there is one quantity common, like A, C, C, then it will be 0. Whenever one quantity is common, its answer will be 0. It is directly asked in the several examination. So this is all about the cross product of vectors. This was cross product of vectors. I think this video become very useful for you. This is very useful for coming examination as well as in competition and 11th and 12th. So this is very useful in several other chapters also, because its application are conducted to perform numericals. So this is very useful. So please do subscribe, share and like our YouTube channel. Thank you very much.